Well, we have this Hewlett-Packard 5315A calibrated now to within about a tenth of a hertz at 10 million. We've provided a calibration hole on the top. I have it covered with a little sticker right now so that looks nice and neat. It keeps the heat in. With this kind of a circuit, the oscillator is temperature sensitive, so you need to let the case warm up and stabilize in temperature before you're going to get the most accurate frequency out of the unit. So I let it warm up for 24 hours, and utilizing then the calibration hole, I was able to calibrate this thing to within a tenth of a hertz, which right now you're getting 10 megahertz to better than a hertz. And if I turn up my time delay, we'll shift everything to the left. We'll pick up an extra digit, and you'll see that we, okay, now the 1 is shifted over, and we are reading 1, 2, 3, 4, 5, 6, 7, 7 zeros and a 1 right at the moment. It's been flashing, and there's all zeros. So we are better than a tenth of a hertz at 10 megahertz in calibration at this point. And we'll check it later. We'll let it go cold again, turn her back on, see how she comes in cold, and then how long it takes to get back to cal. And we'll report that to you as well. This unit is in prime shape, very nice looking, clean, no scratches on the face, no scratches on the face plate. See if I can catch a little bit of a shine here off of the plastic. We can do it this way. There we go. So as you can see, no scratches on the plastic. Very nice looking unit, very clean. No damage to the stand. You saw the interior, very clean in the interior. Nice unit. Okay. We'll come back and check it out later. Alright, this HP5315A has been off overnight, and we're going to go ahead and turn it on. I have already pre-warmed the distribution amplifier and the rubidium, which is in lock right now. That's the green light. So we're going to go ahead and kick on the power here and just see how far off we are while cold. Okay. We are 30 hertz out, roughly, cold. And we should start warming up here, and I'd say in about 15 minutes we'll take another look at it, see how we're doing. Alright, well, it's been exactly an hour, and we are now within 5 hertz of the 10 megahertz signal, so we're still climbing too. We're going to keep letting it go. Well, we've been running about 2.5 hours, and we are now approximately 1 hertz off, but we're going to check that. We'll turn our time gate up here so we pick up an extra digit. It'll take us approximately 10 seconds to get a good cycle on this, but okay, so as we can see, we've hit 9,999,999.8, so we're within 0.2 of a hertz of being a perfect 10 megahertz, and it's been about 2.5 hours. A little wobble here. Looks like we just, there we are, back up to 2. I would suspect that I'll check it again in the morning, but I'm going to suspect that we will achieve our 10 megahertz, and we should hold. We'll verify it then. Well, it's been approximately 24 hours, and we just made a minor tweak to correct about a half a hertz drift on this thing. So we're going to see now how she holds in the next 24. Alright, so here we are, approximately 24 hours since last night. It's 7:42, and just turned on the rubidium source, got it to lock in, and we see that we are reading right now within 0.2 of a hertz. It's been kind of vacillating between 0.2, and as we see here right now, we're up to 10 megahertz right on the nose, but so anyway, I'm going to say we're within 0.3. We'll give it another try. Okay, well, it's 5:38 in the evening or afternoon, and I've got the rubidium source running. I've got the distribution amplifier up and running, and I'm ready to turn this unit on. This unit is cold. It's been sitting here since this morning off, so we're going to turn it on, and we're going to observe what kind of a frequency response we get. Let's go ahead and turn the gate time down. Right now we're reading 9,999,978, so we are 22 hertz off. And that's coming in cold. Not too surprised by that when you look at the specs. But we're going to warm up here shortly, and we'll come back and check and see how we're doing. In fact, we already see that she's coming up. I can see that last digit just changed. Well, it's been approximately 35 minutes. And we are at the moment reading within 0.7 of a hertz of the 10 megahertz that's being applied. So about half an hour we have picked up roughly 11.5 hertz at this point. But we'll check back in a little while. Well, it's about 8 o'clock right now. We've pretty much settled into temperature here, and it looks like we're within approximately 0.2 of a hertz. There is a little chatter on it, so we'll say up to a half a hertz maybe of fluctuation maximum. Most of the time it's going between 0.8 and an even 10. But it looks like we've maxed out. It hasn't moved upwards any in some time now. Alright, we got her adjusted dead nuts again. She's reading 10 megahertz to better than 1/10 of a hertz. So we're going to let it rest, or let it go for a little bit longer just to see if she holds. And we're going to turn it off and try it again. Okay, it's 12:38 at night. I'm getting ready to turn on the unit. She's been cold. We're going to see where we start out at here. Okay, we are starting out at 9,999,978.5. So we are 12.5 hertz, no, 22.5 hertz off. And she was starting up, but she's already starting to warm. I'm going to let it go overnight. I'll check it again in the morning, and we'll see how she did. Well, we fired it up again. It's about 6 o'clock, 6 p.m. And it came in about 2 hertz shy. And we are running right now, well, yeah, it's about 1.9 hertz off. So I think it's going to pick up here shortly, and we're gonna see what it does when it evens out. But it seems like when it's running, if it's measuring 10 megahertz and we're using up all of the digits and the power and so on, I think that it seems to warm up a little bit inside and shift just slightly in frequency. Probably a very normal thing for this particular unit, looking at its specs. But we're going to verify that again, and we'll see what she does. Okay, 9:59 p.m. and we're running somewhere between 1 and 3/10 of a hertz over. We seem to be basically stable, bouncing back and forth between 1 and 3. So that's looking pretty good. Well, as you can see, we're down around a tenth of a hertz right now, of 10 million. And we just went up another tenth. Maybe she'll pounce down. But in any case, we'll say we're within 2/10 of 10 million hertz right now on this unit. Alright, we're reading right now 140 megahertz on this 100 megahertz counter. I'm going to step her down. There's 130. There's 120. You can see the overrange indicator. That's where the 1 would be. There's 110. Alright, here's 100. And then we're going to go, here's 99. In fact, let's give ourselves 99,999. Alright. So we just went over there. Back off just a hair here. 99,999,000 and so on. So we're going to go ahead and take ourselves down. Let's go 80. 70. 60, 50, 40, 30, 20, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, at this point we're going to switch over to a different generator. We'll use the hp5315B, and we'll take her from 1 million down. Okay, we're reading a 900 kilohertz signal now coming from this hp5320B. We're going to take her down in frequency, and we'll go right now. Let's try 800, 700, or 700, sorry, 600, 500, 400, 300, 200, 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Alright, that's 10 kilohertz. There's 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, now we're at 900 hertz, 800, 700, 600, 500, 400, 300, 200, 100. All right, 90, 80, 70, 60, 50, 40, 30, 20, 10, 'All right, we're at 9 hertz. Eight, 7, 6, 5, 4, 3, 2, 1. There we go, 1 hertz. No problem. I'm going to stop there, but essentially, I mean, we could go further. Oh hell, let's try it. It's 0.9. .8 hertz. It's reading as 800 millihertz. 700 millihertz. It's 0.6, 0.5. Alright, at this point I think I'm going to turn my gain up a little. There's 0.5, 0.4, take our gain up all the way. 3, 200. This would be 0.2. Got it. Okay, this would be 0.1 hertz. There it is. Reading is 99 millihertz. That's pretty spectacular. So this unit will come with a new set of leads and with a beautiful manual on the 5315. This is a beautiful service manual, as you can see. Service manual has everything you'd want to know about the unit, how to use it, its theory of operation, maintenance on it, parts lists, and then I went ahead and incorporated some very nice prints. These prints are in 11 by 17 format so that it's easier for you to read. So you'll have the whole ball of wax. Beautiful counter, nice manual, good set of leads. Happy bidding.